Hello everyone, my name is Shelley from Outlook Center at University of Bern. I'm going to present you the paper Informer, Interpretability Funding Monitoring of Medical Image Deep Learning Model. Today, the deep learning model shows us promising performance on many medical image analysis tasks. However, as is shown in literature, model can be overconfident in their prediction. So it's important to understand the model and be able to estimate uncertainty so that we can do quality control on the model prediction. Methods like entropy-based ones and test-time augmentation exist, but they only focusing on using the model output to evaluate the model uncertainty and ignored any information floating inside the model. So the ascendancy map is a heat map revealing the weight of the attributes towards the prediction, as you can see on the right here. And it can be computed by class, so that instead of using the model output, this paper explores the possibility of using the attributes revealed on ascendancy map to estimate the model uncertainty. We hypothesize that the class distinctiveness of the ascendancy map may provide information on model uncertainty, which can be used for prediction quality control. And here's the proposed interpretability class distinctiveness module. And every node here is a ascendancy map of a class, so it's the S. And we can see that there's 5 classes, and D is the cosine distance between the ascendancy map. And we calculate the pairwise cosine similarity between the ascendancy map except for the self-comparison. Then we get the vector V for every class and sum the elements of the vector to obtain the class distinctiveness representations for every class. Then the higher the class distinctiveness, the more certain the models towards the prediction. And intuitively, this means that if the model tends to give an average ascendancy map for classes, then the model is more unsure about the prediction. And in the experiments, we use CheXpert dataset, and it's a public X-ray dataset coming with challenge. Following the CheXpert challenge, we're also focusing on 5 pathology, which are atelectasis, cardiomegaly, consolidation, edema, and pro-effusion. And we evaluate across ascendancy method interpretability methods, which are LRP and input times gradients. And the predictions that are defined to be highly uncertain, then when passing the informer quality control are then flipped. This is because we are evaluated on a multi-label dataset, and every class will be considered as a boundary class. And the quality control methods will be evaluated on an average F1 over 5 classes post-flipping. The flipping is determined by the thresholds on obtained on the validation datasets, and our performance will be evaluated on the test set. And here's the results of the informer compared to the baselines on bootstrapped test set. There are 30 test sets in this evaluation, and we have 2 baselines. One is predictive entropy, and the other is test time augmentation. We can see that the median of the both variants of informer is higher than the baseline, and so is the lower quantile. And we can see, which demonstrating that the significance of informer on quality control over the baseline. And overall, we propose a new novel interpretability-based quality control methods for multi-label dataset in our multi-label classification in our paper. The proposed informers outperform the baseline, and the methods focusing on estimating the model uncertainty by looking at the model gradient float instead of using the model output, which is a novel way to evaluate model uncertainty. And many multi-label studies apply AUC as an evaluation matrix. However, it's a matrix over thresholds, and when you want, it's not optimal when we want to give predictions with a chosen threshold. And F1 would be an evaluations of a chosen thresholds and also considering the class imbalance in the dataset. Informal quality control methods by evaluating the model uncertainty is also useful for enterprise model in which we do not have access to a logic value. There are many further works need to be done in this project. And also, for example, applying Informer in more datasets and more models, and we are also exploring a retrieval-based variant of Informer, which giving a promising results currently and hopefully will be upcoming soon. And GraphCam was also experiments in our experiments. However, the performance of it is less good compared to the ones that have been shown. We think it can be because of the sensing map generated by GraphCams can be a bit blobby and less focused compared to other methods. Overall, this paper gives a novel ways of estimating the model uncertainty and the methods of prediction quality control on multi-label datasets. Many thanks for your attention, and we will have a poster at Unsure Workshop in MICA 2024. And if you would like to have a discussion, I'm looking forward to meet you soon in Marrakesh.